Hi, welcome back. I want to continue on the last session that we have covered. The last session we talked about um, correlation analysis between two variables in a data set. We chose this particular data set called sleep, health, and lifestyle from Kaggle. Using this data set, we looked at the correlation between the quality of sleep and physical activity. And then we noticed some interesting facts about how that is different, distinctly different between two categories, male and female. The way I would interpret is um, category one, there is a trend, positive trend. Category two, there is a flat line, pretty much no relationship or no correlation, rather than interpreting it as there is a trend for females versus there's a trend for males, because we don't certainly know this is a sample that is representative of the population. That's one thing I want to keep in mind while we progress forward. The way to understand this whole thing, the whole exercise, is to identify trends and build a model. Today, we're going to build a model, which is the step two of this journey. Let's get started. I'm going to start a notebook from this data set. Kaggle gives us this great quick pivot opportunity to create a notebook and get started right away. I really like that part. We're not going to spend too much time building our own notebook. So I'm going to call this model training health dataset. Okay. And then kick off this code here. While that is being executed, I do want to give a roadmap of how we were going to progress forward and train a model and test its accuracy today. I would first initially build a roadmap and the number, I'll write down the steps in a detailed way and then fill up the information as we go forward. That way, we are going to be very quick and efficient. So, what I mean by that is I'm going to drop in all the steps that we are going to cover today. Step one is importing libraries, right? Libraries. And step two, we are going to identify the variables that we want to select for the model. Step three is selecting train and test sample splitting, sample split, I'm going to call that. And then select the model of choice. That's going to be the next step. And then we have actual training of the model, train the model, then accuracy testing. So after training the model, we are going to see how accurate it is against the equation that we built using the training data set. Then we will go ahead and get some model fit statistics and then print coefficients. In this case, today we're trying to look at simple linear regression. That's how we're going to start. We can build more complex models like decision tree algorithms going forward, print coefficients. Okay, now we're just going to pull up these, skip forward a couple of steps to save time. We wanted to import the libraries that are needed here, so we already did that. And then I'm reading the data from the CSV document, um, and then quickly running some summary statistics to understand what variables are in the data set. So if you want to take a quick look at that, we have person ID. It is the most granular level, or the primary key here is the person ID. We have age, sleep duration, quality of sleep, physical activity, stress level, heart rate, daily steps. These are the continuous variables. There are some categorical variables which we will not be able to see here in this view. Um, but then the key variables we want to look at will be the quality of sleep. This is the Y variable, and these are the X variables or the independent variables um, we want to use for our model. So let's just dive to the second step and cruise forward. Here I'm going to denote vari the dependent variables or the independent variables as X, and the predictor variable or the output variable, I'm going to denote that as small y, just the usual um, format to define variables. I'm going to bring in my X variables here. I'm going to say the physical activity is going to be a factor for quality of sleep. So I'm going to bring that. And then I'm going to bring in age. I have a feeling that will be, we can use age in this case because it's a continuous variable. So I'm going to get that as one of the independent variables also. Um, then I want to also bring in the stress level. It's like a chicken and egg. Less sleep or low quality sleep can cause more stress and vice versa. But I would like to use that to understand the relationship here. Heart rate, I'm not going to use. Daily steps is a good metric to use. But however, I think there is going to be collinearity, multi-collinearity, meaning the information that is going to um, that we are going to fetch using physical activity will be the same as daily steps. I would, however, use it in the model to see how the result is going to be and observe the coefficients. And our y variable is simple. It is the quality of sleep. We already talked about that. So we're going to bring the quality of sleep here, and then I'm going to get the model, the type of model we want to train here. In this case, it is linear regression. Oh, sorry, that's the next step. So we're going to copy that down here. We're going to split the data sets, which is X train, X test, Y train, Y test. In this case, we are going to train, test, split, which we imported from scikit-learn. Going to call out X variables, our output variable test size is, I'm going to start with 20%. We can change that, and random state is another variable we need to call out. This is an arbitrary number. For most data scientists use 42 as a random state. There's no particular reason for it. You can also change it to 60, doesn't really matter. 42 is the norm. They've been using it forever. Jump to the next step here, which is model training. Model.fit is X between the X trained and Y trained. That's a sample we carved out above in our train and test split step. Then we are moving on to the accuracy testing of this model. That is Y predict. Y predict is equal to model dot predict using the test sample. So basically using the equation that we obtained from the training data set and using it against the test input variables in the test and understand the error rate, which is exactly our next step, very next step here. I'm going to use a couple of model fit statistics: mean squared error, root mean squared error, and mean absolute error. So I'm going to bring that in, and basically we are understanding the difference or the error rate between the test and the predicted variables. Um, print going to use a formatted string here, mean squared error, call out the MSC. This is the variable we need. I'm going to use the same thing here for root mean square error. It is the same syntax, same function, except one simple addition. We're going to say squared is equal to false. For that to work, and change this to RMSE, root mean squared error. And then the next one we want to see is mean absolute error. We're going to label that as MAE and change that to MAE here as well. And this is going to be mean squared, mean absolute error. Okay, we got that. Change this to mean absolute error. Okay, and now I'm going to print the coefficient, which is the weightage of each of the independent variable and the intercept. Coefficients model. This is the syntax. I would not even worry about remembering it. I would just look it up as needed. Pretty similar syntax for printing the intercept. And I'm going to call that as intercept over here. Looks like we need everything we need. I'm going to start running the whole model here. Um, we have a tiny error here, root mean squared error and mean absolute error. There's an error. Okay, I don't think we need this additional value for mean absolute error. Okay, and try and run this again. Okay, we have the model output here. The error, mean squared error is 4, root mean squared error is 2.02. That's pretty good. And mean absolute error is 1.6. The coefficients is basically the value or the weightage of individual variable. The physical activity is contributing 1.87 as the coefficient, and the age is contributing 0.225. It is insignificant. So I will remove the age and rerun it for actually narrow it down to female, which we observed in our last session has a significant impact on quality of sleep. So I'm going to remove age here and actually go back and look at the weightage of daily steps is much better. So I'm going to use, to remove multicollinearity, I'm going to use daily steps as the variable and stress level. These are the two variables I want to use. And I'm also going to use this carved out data set for females to see how our model is performing. Just need to change that over here and rerun the whole process. Okay, that's much better. I want to, just how we observed, there is a positive correlation or significant impact of quality on quality of sleep as the daily activity increases, for female category especially, and for male category, I think it's going to be interesting to see if the male category has a different impact. That's what we observed last time also. So I'm going to change that to um, male and see how that's going to change our equation. Interesting. It's a negative correlation. This is very interesting. And the intercept has changed. Our model fit statistics are slightly better, but very interesting. I'm going to change this to female one more time and observe the results of the model. So the model is indicating there is a positive impact with daily activity for females and negative impact for males. That's all for today. We'll catch up again.